Hi, your lesson today is on angles and quadrangles. By the end of the math lesson, you should be able to use letter notation to identify angles, describe properties of quadrangles, and construct or make quadrangles, triangles, and angles. So let's get started. There are three kinds of angles that you're going to meet in this math class. Now, to get an angle, we need two sides that are going to form an angle, and they come together at a point called the vertex of the angle. One of these angles you might already be very familiar with. It's called the right angle. It's where the two sides meet at a vertex that when we measure it is 90 degrees. Sometimes you might see it noted as a 90-degree angle with a little square box in the corner. For angles that are more than 90 degrees when measured, we say that they're obtuse. That means that the angle is larger than a right angle. It might look like something like that. That's just an example. On the other hand, if it's less than 90 degrees or smaller than a right angle, we say it's acute, a very cute angle. Sometimes they look teeny tiny. If you were to measure it, they might look like that. So those are the three angles you're going to meet in this math class. Here's an angle that needs some filling in. We want the vertex of this angle to be B. So where should B go? Right on the vertex, obviously. So we're going to drag the endpoint there. Got some rays going on here now. And we're going to call that B. So that's vertex B. Now, just for kicks and giggles, let's throw our endpoint C and endpoint A on here. And we want to be able to name this angle. So how would you say this angle? One way that you could say it would be angle ABC. Oh my goodness, let's scoot that over for you. You could also name it angle CBA. Notice I started at A, traveled down to B, over to C. I also went the other way. I started at C, went to B, to A. You cannot jump around. You can't go ACB or CAB. It has to go in order, and your vertex has to be, absolutely has to be the middle letter. Now that you know the three types of angles, let's talk about what happens when those angles get together, or their sides get together. When three sides are joined together, you know this, it's called a triangle. 1, 2, 3 sides, 1, 2, 3 angles or vertices. So what happens when four sides join together? If you said a quadrangle or a quadrilateral, you'd be correct. Now quadrilaterals can have fancy names, and we're going to talk a little bit more about some of the properties of them now. Here's a quadrangle that has all four sides in equal length. So if we were to measure these lengths, they'd all be the same size. They also all have right angles. So if I were to go around and put the boxes in, they'd all be the same 90-degree angle measurement. So what do we call this quadrilateral? We would definitely call it a square. Now imagine this. If you had a square that was made out of plastic straws and twist ties, and let's say you're going to tug this vertex and this vertex, the vertices opposite each other. You're stretch them out. Watch what happens. Suddenly your regular square becomes a squished square. It looks like Mr. Nutty sat on it and squished it. Our angles are no longer 90 degrees. Let's take a look at our sides though. Opposite sides are still the same length. We haven't gotten new straws, we haven't changed the lengths at all, we've just changed the size of the angles. So this new shape, this squished square, is called a rhombus. We can also have a quadrangle that has two sides of one length and two sides of a totally different length. The pairs of opposite sides are the same length, and the angles are all right angles. Now if you get confused when I talk about pairs, think about a pair of socks. We know that a pair of socks has two equal socks. So when we talk about a pair of opposite sides, that's going to mean two sides. And in here, we're talking about opposite sides. So here, this pair of opposite sides are the same length. Not when I draw it, but you see what I mean. And this pair of opposite sides are the same length. And all of the angles are right angles. So you know this shape as a rectangle. Now, just like we did with the square when we made it into a squish square or a rhombus, we're going to squish our rectangle. So we're going to tug at those opposite vertices and watch what happens. Our rectangle has turned into something where we no longer have right angles, but we still have the opposite sides the same length. But now we call this a parallelogram. So a parallelogram is a squished rectangle. Now, if you had your student resource book, I would have you open it and look at page 100. We're not going to do that right now, but I do want to talk about some similarities and differences with the thinking map between parallelograms and kites. Remember, our parallelograms are squished rectangles, and our kites we haven't talked too much about yet, but think about the kites that you fly in the sky. Some similarities. Both parallelograms and kites have 4 sides. That's right. They're both quadrangles. They also have line segments, 4 of them each to be exact. But that's where the similarities kind of end, because for parallelograms, there's 2 pairs of parallel sides. Remember socks, 1 pair is 2 socks, so 2 pairs of socks would be 4 socks. So there's 2 pairs of parallel sides with parallelograms, and the sides opposite each other are the same length. But with kites, it doesn't have any parallel sides or pairs of parallel sides. And the sides of equal length are right next to each other. So in this little kite, this side and this side are equal length. This top right and top left are equal length. All right, that wraps it up for today. We'll see you later.